Everybody, and welcome to lesson 7. I think it's 7. Let me double check that real quick. Lesson 7 of our Pytorch tutorials. Yeah, lesson 7. So deep learning with Pytorch, lesson 7. We're going to finish up chapter 4 in this video. We're going to go through this series of code here, and we're going to go through 5. So this is a time series data, and this is a text data written by Jane Austen, who is the author of Pride and Prejudice. The big thing to learn out of this lesson is one-hot encoding. So what one-hot encoding does is it essentially takes non-numerical data and represents it using numbers. So if we had a color variable like red, green, or blue, or a pet like dog or cat, we may use one-hot encoding to categorize that data. So let's see if it shows it anywhere. Okay, so here's a good example of that. Example 2 would be red, example 3 would be green, and example 4 would be blue. And it basically just creates a matrix and sets it all equal to 0, but if it is of that category, it will set it equal to 1. So this is a way to take data which is not numerical in nature and make it numerical. And sometimes the line is a little hard to tell, and we'll see that in this code here. So deep learning with Pytorch. This is the section we're on, 4.4, where we're dealing with a bike sharing application, I guess, where you rent a bike rental app, and our data is a lot of data that has to do with that. It is the day of the month, the season, the year, the month, hour. Is it a holiday? Is it a day of the week? Is it a weekday? Is it a working day? What's the weather situation? So here's an example of one that is going to need to be one-hot encoded. And the reason it needs to be one-hot encoded is because 1 clear, 2 mist, 3 light rain, and 4 heavy. So if we leave this in a numerical sense, like you could technically say that, okay, if you have clear plus mist equals light rain, and that's not true, right? So that's why we have to one-hot encode this area of data here. Temperature, some of the data we have to normalize, and some of it we have to one-hot encode. So that's why when you're dealing with the data set, you kind of have to go through all this on your own. Wind speed, that would be a number. Number of casual users available, number of registered users, and the count of rental bikes available, I'm assuming, on that one. So we're going to go through this whole code now. So kernel, restart and clear output. Okay, let's do that. And edge items, I'm going to go ahead and set that to 6 so that we can get a good view of certain things. Threshold 50 and line width 75 is fine. Let's go ahead and run that. So now we're going to pull up our CSV, NP load text, so that's numpy load text. The data type is going to be a float 32s. The delimiter, that's what separates the data, is a comma. Skip rows 1, converters, and then bikes equals torch from numpy. So now we're taking this numpy array and converting it to a Pytorch tensor, and then we'll look at bikes and shape. So this is the tensor bikes. Okay, so that's what it looks like there. And remember, we set our edge items to 6, so it gave us the first 6 and the first 6 here, the first 6 that way, and the last 6 and the last 6 that way. And we'll look at the size here. So we have 17,000 cases, and 17 variables. So we can look at our Excel spreadsheet of this one here. And I guess the way this CSV is saved is that it is comma delimited. So if you mess with it, it'll save it in a different way. I don't know how to organize an Excel spreadsheet to make it comma delimited, but I'm sure you could Google it and figure it out. So here's the instant. Here's the day, and then the season. So I guess eventually that changes to 2. I guess there's 4 seasons. Year, month, hour, blah, 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 blah. Weather. So here we have 2, and then it goes to 2, and then it ends up being 3 later in the day. Temperatures and number of bikes available. Or maybe that's number of bikes being used. Yeah, that would make more sense. Because there's not a lot of bikes being used here. And this would seem like an hour where a lot of bikes would be used throughout the day, and then less in the later early hours in the morning. In some cases the wind speed is 0. All right, so that all looks good. Let's go ahead and minimize that and get back to the code. So we've just imported the data here. Nothing complicated. So now let's look at bike shape and bike stride. Okay, so the shape, we already knew that. That was written here. In the stride, if you remember, is just, it goes 17. If you think of it, this data as a one-dimensional vector, it goes 17 and then drops down to the next row. 17, drop down to the next row. So 17, let me see if this is 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so we're good to go there. Daily bikes equals bikes.view -1, 24, bike shape 1. So bike shape 1 would be this number here. No. It would be this number. This is 0. This would be bike shape 0 and 17. So we want -1, whatever that would be. 24, that's 24 hours of the day, and then 17 variables. So what we're doing here is breaking it down into a daily view of the tensor. And we can print daily bikes here and then see what all of this looks like. So this is daily bikes 3, so that would be hour 3. We could do 0 as well, and that would be fine. And it gives us all 17 variables there. So this is the day variable. So that's day 2. That's day 3, day 4, day 5, so on, day 6, and on and on. This is the hour of the day, so now we're changing the hour. This is day 1, hour 5. And that's the variables that impact that. The shape of our daily bikes tensor is different than our bikes tensor. It is 730 by 24 by 17. And what was this? That's stride. So it goes 408, drop to the next dimension, 17, drop to the next dimension, and so on and so forth. All right, so now we're going to transpose it. Okay, and then we'll see what the shape looks like then. So I guess they just wanted the hours to be in the last category there. So now if we did print daily bikes, we'd have to change that if we wanted different views. This same line of code now, if we want to put that in here, our hours are now at the end. Our variables, if we want all of the variables, we'll put a colon here for all, and then this would give us the same thing as this, only that's a 5, so we could change that to a 5 if we want to. And we'll get the same. Oh, we did not get the same thing. Bike shape is 730 by 24 by 17. Oh, because we transposed it again. All right, so let me restart the kernel and clear all outputs. Some codes you have to be careful, because if it's like a transpose and you say go ahead and transpose it, you will transpose it twice, right? So that's not what we want to do. Hopefully this works this time, and it did. Okay. So if I ran this line of code again, it will retranspose the matrix, right? So that's why it didn't work, because I was running it for the second time. So this is equivalent to this after transposing the matrix. Okay, so now we'll look at the first day, and we're doing the one-hot encoding here. So the first day we're saying colon 24 long. So if we want to maybe, let's print this so we can add some more things to look at what's going on here. What is the shape of first day? It is 24 by 17. So it's the first day, all of the variables of that day. Okay. But the main thing that we're doing here is weather underscore one hot. We are torch zeros, first day shape of the 0th dimension, comma 4. If we look at the first day shape, this is the first day shape, so that's 24. So this, you could literally delete this and write 24. All that means is 24. It's referring to this dimension here. So 24 by 4. So the reason that there are 4, if we're going to one-hot encode our weather dimension, if you recall, right here, there are 4. That's why we're doing that. So nothing too complicated there. We need to one-hot encode it with the dimension of 4. So we'll have 1 for 1. We'll have 4 lengths of zeros. Maybe if we print it, it would look even better. So let's say print weather one hot. All right, and there's the tensor. It's an empty tensor, but so when we plug it in, this 1 would go here. This is a 2, so then the 2 category would get a 1. The 3 category would get a 1. So we're just rearranging this so that we don't end up with the weird numerics of, like I already explained, 1 plus 2 equals, or clear plus mist equals light rain, or light rain minus clear equals mist. Mist plus mist equals heavy. It doesn't make sense. So we have to one-hot encode it. Daily bike shape. So that's, we've already printed that, right? We already knew that was the case of daily bike shape. We've just rearranged our original data in the form of 24-hour schedule there. All right, so now we're inputting the one-hot numbers, and I guess this is how you do it. Dimension 1, index equals first day, colon 9. So 9 is, if we remember our first day, this is the 9th column of that. Okay, so if we say first day dot shape, it's 24 by 17. We're saying all 24 hours of the 9th column of this 17 here, and that is just very simply this value here. This is the 9th column, J. So index equals first day, 9th column. Unsqueeze that, so add a dimension, long minus 1, value equals 1. So this line of code is what creates our one-hot tensor, so to speak. So here we have it. We've we've inputted here. So the first 5 are 1, and then the 6th one would be a 2. Let's double check that. 1, 2, 3, 4, 5, and then that's a 2. So now we've proved that that is the case, and we can move forward. Some of the ones at the end of the day as well are 2, and we can see that very clearly that at the end of the day it looks like there are some 2s in there. Okay, so now we use the command here, torch cat, that is concatenate, and concatenate means to combine. So we're going to combine bikes, the first 24 of those, with weather 1 hot. This is another line of code that we could not run more than once. So let's run it. Or actually we can run this line of code more than once. We can't run this line of code more than once. So let's look at the shape of this thing. 24 by 21. So what have we done here? We added our 1 hot to our original matrix. And what that gives us is, instead of 17, we've added 4 columns here. 1, 2, 3, 4. And that would be 21. 17 plus 4 is 21. So that's how we end up with that. I think that you would also need to delete this one after you're done. I don't know if they do that in this code, but it's okay. We're just showing how to do it. So it wouldn't be hard to delete 1 column. We could figure that out if we had to do that on our own. And this isn't, we're not storing anything here. We're just running it. So I think it had like a 1 here, right? So let's see what they were trying to show us there. Oh, okay. So this is the first line, and then if you could imagine putting this 1, 0, 0, 0 here, we could put that right here, 1, 0, 0, 0, and that would be on the first one. So that's how we end up here. We actually hit 1, so we got this line. That's always confusing. I told you guys that would be confusing. So we got this one, which ends in a 40. It has a weather of 1. If we go back to it, we see that we're looking at that row. Okay? So now we are going to say daily weather 1 hot, torch zeros, daily bike shape 0, 4, daily bike shape 2. And let's look at what we get here. I think what we did here is that we took... Oh, we're just making another empty 1 hot. Okay, another torch zeros. So we did it here. 1 hot, torch zeros, first day shape. So we did it here, but we only did it for the first day. Now we're doing it for all of them. So we could do that again. We can run this line of code twice and it won't hurt anything. But what I'll do instead is I'll just write B. That's a hotkey. If you're selected outside of the box and you press B, it will put a box below it. Let's just copy and paste this real quick. Or you know what we could do is say, oh, I already did it, so I don't need to do it. Daily weather 1 hot shape, right? So 730 by 4 by 24. That's a matrix, or sorry, a tensor of zeros in this specific shape. This is 730, and this is 24. And that comes from up here above 730, 17, and 4. But we only need 4 because we're 1 hot encoding a categorical data with 4 categories. Now we're about to put that in. We'll just run this empty box. And this is how we put it in, the same way before. Daily weather underscore 1 hot scatter. 1, yeah, we're going from the 9th one here. I guess you hit long, you unsqueeze that, and then -1, and this is where we're setting it equal to 1. You could look at this dot scatter command and see what each one of these is doing. But ultimately, we end up with that. Now, I do remember if I run this one twice, I will add another. No. Sorry, I keep thinking it's coming. It's this one. If I run this one twice, it will add another 4 to it. I will reconcatenate. So on this line of code, so now in this line of code, we created the one hot. And on this line of code, we concatenated it to our original tensor. So daily weather, one hot, daily bikes. We're combining those two tensors, and what we end up with is a tensor of these dimensions, just like before. Same situation, only this time we didn't do it for just the first day only. We did it for all of the data. And again, an issue that I'm seeing is that they did not delete this. Normally when you one hot encode something, you would go back and delete row 9, but that's okay. If you rerun this line of code, it will concatenate again, because we're saying daily bikes equals daily bikes add on that. So now our new daily bikes would iterate to here, and we would end up with a matrix of 25 here. So I'll do that at the end to show you what I mean if that's confusing. Oh, it just did it, didn't it? Oh, no. This I was going to say, they just deleted row 9 here. They're not deleting column 9. What they're doing here is saying every value in column 9 minus 1 divided by 3. So that would normalize it. It's the minimum divided by, well, not the maximum. I get they could have just divided by 4 there, right? I wonder what they were going for there. We could just transform the variable so it runs from 0 to 1. So all they're saying is that it does run from 0 to 1. That's true. That's one way to do it. If you subtract, if there's only 4 values in here, 1, 2, 3, and 4. 4 minus 1 divided by 3 would be 1. 2 minus 1 divided by 3, 2 minus 1, so that would be 0.333. And 3 minus 1 would be 0. So you would have it 0, 0.33, 0.66, and also a 1. So it does go from 0 to 1 in a smooth interval. So that does work using that equation. All right, so here's another way they're doing. Oh, so now we're going to normalize another piece of data. That now we're looking at the temperature. So the temperature of the daily bikes is column 10. We're taking the minimum temperature and the maximum temperature, and we're doing this normalization equation. Just in the last video I said you can type in normalization equations, and one of the first ones you're going to see is linear scaling, x minus the min over max minus min. If we look back, that's what we're seeing here, x minus min over max minus min. Let's go ahead and run that line of code. And we could even print temp if you want. Like, let's hit B and say print temp. Sorry, a little late, not spelling very good. Now all of the temperatures are normalized to a certain scale. They were already between 1 and 0 because they were in decimal form, but now they are normalized as well. So you just got to kind of learn what data you have to normalize and what's the best way to normalize it, and it's a lot of touch and go there. Daily bikes, we're looking at the 5th day here, or the 5th hour. That's the first hour. Yep, everything looks fine. we still have that. We're accounting for this twice. So if we were going to feed this into a neural network, that would be an issue. It's almost like it's like counting it twice. Row, column 9, and the 1 hot here. If you think about it in like an Excel form, that we still have column 9 in this tensor. So we could just delete that out, but we'll just leave it. And this finally, this is just saying, hey, here's another way to normalize the temperature. This is the statistical way. X minus the mean over the standard deviation. Boom, boom. We're done with this code. All we're learning how to do here is upload the data. Take some data and upload it into a form that will be able to be readable in a neural network. Now, where were we here? I'll just run this again to kind of show you that this, if we said daily bikes 1, it would be different. But because we're using the same variable, daily bikes equals daily bikes add daily weather 1 hot. Now when we run this code again, that's what I was talking about. Now it goes to 25. So we just keep adding 1 hot encoded vectors to it. Okay, so that's that, and now we're going to switch over to the Jane Austen text of Pride and Prejudice, a book that I've never read and am never going to read. Let's run that. Let's import the text here, and sorry to anyone who's a Jane Austen fan. I don't read a lot of books, honestly. Maybe The Alchemist. I like that book. So here we have this. We're saying edge items equals 5, threshold 50. There's the text data, and we're saying text equals f dot read. So now our text is in this code. Let's restart and clear the output too, because I already ran this. All right. So lines equals text.split / new. So every time there's a new line, we are accounting for that. We could say lines dot shape. Oh, I don't think that works, right? Because this is not going to be a string object has no shape. So that's the data types. We're not dealing with numbers here. We're dealing with a string. So what we would do, I believe, is say length of line and 70. So we have 70 lines. Oh, no. We have 13,000 lines, okay? The length of line is just line 200. So that's 70 characters, I believe. So if I delete that, can we see print? Is that how that was? Okay, there it is. Impossible, Mr. Bennett, impossible, when I am not acquainted with him. So length of line, 70. This is 70 characters long. Letter T equals torch.zeros. So the thing about text, okay, you kind of have to think about this one-hot encoding thing. All right, what are we going to one-hot encode? Are we going to one-hot encode every letter? That's one option, because there's actually less letters than there are words when you think about it. There's only 24 letters. Add in the commas and all that stuff. I think later in the code we'll see how many that they use, or maybe it's even 128 here. But if you one-hot encoded every word, you would have an insanely long piece of data there. So there's kind of like a trade-off between the two, and they write about it pretty well in the chapter. I've never actually done any machine learning on text, but it is something that's coming along. If you just one-hot encode the letters, you might not get any data coming from how the words are organized, which is important for reading. All right, so letter T equals torch dot zeros, length line 128. So we just made a letter T shape. We just made a tensor of zeros of 70 by 128. Now we're going to enumerate that and put that in here. Now we look at letter T shape again. Still 70 by 128. Ordered letter, if ordered letter is less than 128, else 0. Letter Ti. I think that this line of code, let's just check and see what that was. The index where one has set to score from. This text uses directional double quotes, which are not valid ASIC 2, so we screen them out here. Okay, so ASC2 is a method of one-hot encoding our text data. So what this next line of code does is it's called clean words input string. We're going to get rid of all of the punctuation. We're going to replace all of the uppercase letters with lowercase letters. And that's that. So now we look at it, and now our data is stored in a different method. It is stored, instead of this is how it was stored before. We cleaned the words. Here's line, and here's words in line. This is clean words. So now it looks like this, separated by commas. So we got each word here. So now we're going to clean that. Now we're going to get word list, and we're going to clean all the words in the entire text. Word to index dictionary. I believe this line of code is maybe one hot encoding this. This is what we end up with. Oh, so we just, as I was just saying, you could either one hot encode the words, or you could one hot encode the letters. And what we're doing is one hot encoding the words here. So you end up with a total of 7,000 words, I believe. 7,261 different words. Which is quite a bit. Okay? And the shape of it now is, for this word T shape, is 11 by this amount. Basically, this number corresponds to a certain word. Impossible is word number 3,394. Mr. is word number 4,305. And so we're going to one hot encode an entire text, which is kind of crazy. I don't know if that actually, I'm kind of excited to see that, if that's how we will actually input this into a neural network. So we'll find out that in the next chapter. Now we just unsqueezed this word T shape to another dimension. This is showing us the opposite way of doing it, which would be one hot encoding it based on characters. So you have all these different characters here, letters. So we could have one hot encoded it that way, and I think you end up with (124) or 128 of them. and you can just kind of type different ones. V is 118. What is let it be? So we need to the main point of this is we need to store these words and letters as numbers in order to feed them into a neural network, because neural networks utilize numbers, or any machine learning algorithm for that matter. Okay, so I hope that's pretty clear. There are two other examples here. I'm not going to get into those. We have audio and video. How to upload those. Video is pretty simple. We did do image, right? So video is just a stack of images, and audio is just a audio file. So basically any form of data that is stored on your computer can be fed into a neural network. So I'll see you in the next lesson. Thank you for following along. The next lesson we will get into chapter 5, which is the mechanics of learning. Okay, thank you.